Have you ever looked up at the night sky, eyes fixed on the moon, and wondered, how did it come to be? The moon, our closest celestial neighbor, has long been a source of mystery and intrigue. Its formation has sparked curiosity for centuries, leading to a myriad of theories which have evolved over time. Among these, one stands out for its compelling narrative and widespread acceptance: the giant impact hypothesis. Today we dive into the fascinating giant impact hypothesis, a widely accepted theory explaining the moon's birth. So, what is the giant impact hypothesis? Prepare to embark on a cosmic journey back in time. Our story begins in the early solar system some 4.5 billion years ago. Picture a young molten proto-Earth, bustling with volcanic activity and bathed in the glow of a young sun. But our planet wasn't alone. Close by, another celestial body orbited the sun. This was Theia, a Mars-sized planetoid named after the Titan goddess, who was the mother of the moon in Greek mythology. As fate would have it, the paths of these two bodies crossed. It wasn't a gentle meeting but rather a colossal collision. Theia, traveling at a staggering speed, slammed into the proto-Earth with an unimaginable force. The impact was so great it's thought that Theia was completely destroyed, its remnants blasted into space. Meanwhile, the proto-Earth was left reeling, its surface molten and reshaped by the force of the impact. But this wasn't the end. Instead, it was the beginning of something truly extraordinary. The debris from the impact, a mixture of material from both Theia and the proto-Earth, began to coalesce in Earth's orbit. Over time, this cloud of debris started to bunch together, gradually forming a new celestial body. This catastrophic event, a collision of cosmic proportions, led to the birth of the moon as we know it. Now imagine the aftermath of this cataclysmic event. The space around Earth was not empty. It was a swirling, chaotic mess of debris, remnants of the massive impact. This debris, caught in Earth's gravitational pull, began to form a disk around our planet. The enormity of space and the raw power of gravity worked hand in hand, pulling together these scattered pieces to create something new and extraordinary. This was not an instant process, mind you. It took time, lots of it. Gradually, the debris coalesced, forming a molten mass. This was the moon in its infancy, a fiery liquid sphere. But over the course of millions of years, this molten mass began to cool down, solidifying into the moon we know today. Its craters and plains, its mountains and valleys, all are the result of this cooling and solidifying process. And there it was, our moon, a silent witness to Earth's history, born out of chaos and destruction. The giant impact hypothesis is more than just a story of collision and formation. It holds key insights into our moon and its relationship with Earth. This theory, as dramatic as it is, paints a picture of a violent past that has shaped the moon we see in the night sky. Let's take a moment to summarize the main points of the giant impact hypothesis. It suggests that about 4.5 billion years ago, a Mars-sized body named Theia collided with the early Earth. This catastrophic event resulted in a debris cloud that eventually coalesced to form our moon. The hypothesis explains the moon's composition, which is strikingly similar to the Earth's mantle. This similarity suggests that the moon's material came primarily from our planet. The theory also sheds light on the moon's size relative to Earth. Unlike other planets, our moon is unusually large, which could be a result of this colossal impact. Furthermore, the moon's lack of an iron core is another mystery that the giant impact hypothesis helps to unravel. If the moon had formed independently like other planets, it would likely have a substantial iron core, which it does not. The giant impact hypothesis has significantly shaped our understanding of the moon and Earth. It's a tale of celestial drama that has profound implications for planetary science. The giant impact hypothesis, a testament to the moon's violent past, continues to illuminate our understanding of the cosmos. The moon, our closest celestial neighbor, has a far more dramatic history than we might imagine. The giant impact hypothesis paints a picture of a cataclysmic event, giving birth to our moon. It's a testament to the dynamic and ever-changing nature of the cosmos. So, let's keep our eyes to the skies, and our minds open to the endless possibilities. After all, every star, every planet, every galaxy has a story to tell. Thank you for joining us on this cosmic adventure. Subscribe to our Universal Universe channel for daily cosmic adventures.